All right, so if we're talking about A times B equals 0, do you get that either A has to be 0 or B has to be 0? To make something equal 0, you can't take two numbers and multiply them. One of them has to be 0. All right. So then, if we move to an equation that typically looks, okay, this is a whole bunch of mathy stuff about it. It's called the zero product property. That is important. You do need to know the ZPP is the words. But basically, you're going to have problems that look like this. And you're supposed to solve them using that property. Let me show you how it works. Do you get that if this part right here were to equal 0, then it doesn't even matter what that part is? It's going to make the answer equal 0. So then, if I'm going to start with a simpler one. Maybe I'll go to this one over here. Do you get that if I put a -6 right there, and for x, that first part, this part right here, will equal 0? And if it's 0 times, I don't even care what I get here. Yeah, it turns out to be -9, but that doesn't matter, because 0 times anything makes 0. So one of my answers is x is -6. One of my answers is, what do you think for this one? 3. X equals 3. Those are my two answers, 3 and -6. What are you doing? Okay, and was the math that was extremely funny? Okay, so I was just talking about this seconds ago. You know where you're supposed to be. Please be there. All right. This one was pretty simple, but if I multiply it back out, it would have looked complicated. X squared plus 3x minus 18. There was the equation to start with. Would you have known that the answer was -6 by looking at this? But it's because they factored it. They took this and they factored it and said, what could I factor this into? X and x plus a 6 and minus a 3. That made it way easier to see, oh, the answers are -6 and +3. You get where I'm going here? All right, let me see if you get where I'm going. Y equals, let me make it even simpler. We'll just say x squared plus 2x plus 1. Write that down. Now I want you to factor it. What do you get when you factor it? X plus 1 and x plus 1. Now, from what I was just saying seconds ago, if I set this equal to 0, which you can when you're doing a quadratic, you want to when you're doing a quadratic, then I can just say, oh, well, what's the answer got to be? X equals what? -1. Now, what's another way I could have got that answer? Another way I could have got that answer is guess and check. I could just keep trying things for x, stick numbers in there, and eventually find one that makes it equal 0. It's another way I could have got that answer. X equals -b plus or minus square root b squared minus 4c all over 2a. Yeah, they all give you the same thing. The answer is -1. All right, so I wanted to go back to that for a second. X equals -b plus or minus square root b squared minus 4ac all over 2a. That's fine, but you need to know that formula. If you haven't got it memorized, memorize it. Good. If you have a question, raise your hand. Otherwise, don't talk right now. Yes. The whole topic is called zero product property, but this one's not a zero product. This is the quadratic formula. I'm just making the point that you can solve this problem a lot of ways, and I'm going to show you how to solve it with the quadratic formula here. B is 2, so I put in a 2 and a 2, and I could put in A is 1 and C is 1, and A was 1. So there we go. It's -2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times 1, all over 2. Just wait. Now I'm going to have, let's see, what's this? That's 0. So it's -2 plus or minus 0. That means I don't have to really even do that, right? All over 2. And what's that equal to? -1. The point is, I'm trying to show you that we're not doing something new here. We're just doing something in a new way. You've done this before. This is getting the answers to a quadratic. The answer to this is -1. -1 is the answer that will make it equal 0. But there's a lot of ways to get the answer to a quadratic. Specifically, there's three big ones. Three big ones you're going to use. This one, the quadratic formula. We just did the quadratic formula. Why would you want to do that? Only because the quadratic formula always works. It even gives you imaginary answers that you can't see in a graph and you can't do with that factoring thing I was showing you. Okay, so that's one way to solve this red equation. The second way to solve it is the way I talked about before, where we could factor it. And that also works really well. In fact, wouldn't you agree that this tells you the answer is -1 way faster? Yeah. So the zero product property thing works really well if you can factor it, but not everything can be factored, right? And if things can't be factored, then you have to use the quadratic. What happens if you have a calculator? Your calculator is very powerful, and it does one thing really well. That's why they call it that. What does it do really well? It calculates, yes, but it's a what kind of calculator? It's a graphing calculator. So I could graph this thing. Guess what happens if I graph this side and this side? That's an equation. That's an equation. Where do you think they would cross? At -1. I graph y equals 0. That's the line that goes like this. And I graph the parabola. And the parabola is going to touch it at -1. And in fact, to be specific, it touches it right like that. And where that line and that line touch, right at that magical spot, the answer is -1. And that's how you could get it by graphing. If I keep coming up with -1, I'm just coming up with it in a lot of different ways. I could graph. I could factor it. Well, today's mostly about the factoring part. So we have a lot of problems that look like this. Can you imagine how hard that would have been to factor? But it's already been factored for you. So then the good part is you just have to figure out what makes this part 0. What would make that part 0? So x equals 7. This part's kind of hard, but let's skip to this part. What would make that part 0? X equals 0. And what would make this part 0? You might want to go off to the side of your paper and say 4x plus 5. I want it to equal 0 and then solve it. 4x equals -5. X equals -5/4. I know you're not going to come up with that in your head super fast, but that's the answer. So there's three answers. -5/4 at 7 and 0. Yes, ma'am. You could have 5 or 20 answers, but most of the time you have 2 answers. Sometimes you have 3. It gets more rare to have 4 or 5 answers. All right, yes, for today's homework, a typical problem will look like this. And that one's going to have 2 answers. One for this part, one for that part. So, if there's more than one x, this has more than one x. Yep, 2x minus 1 equals 0, and solve that. And then 3x minus 4 equals 0, and solve that. So this will be 2x equals 1, x equals 1/2. And over here, 3x equals 4, x equals 4/3. So 4/3 and 1/2 are my 2 answers for that one. Okay, so you set each part equals 0. Set this part equals 0, set that part equals 0. What you are finding is the answers to the quadratic. They're also called the roots. They're also called the zeros because guess what happens when I put this into the equation? It makes it equal 0. That's why they're called the zeros. So they're called the zeros, the roots, the x-intercepts, because if I graph this thing, it's going to be a parabola that touches at 1/2 and 4/3 like that. They're the x-intercepts. And the pen got away from me. The x-intercepts are where y equals 0. So you set the whole thing equal to 0. See? Here's the 0. It's set equal to 0. All right, so one last time. How could there be 3 on a graph? Let's say that you have a graph that looks like this, and then the other line that you have goes like this. It's going to have 3 answers. Touches here, touches there. So you remember, you graph both sides of your equation and see where they cross. So if you had one that looked like this, x cubed plus 3x plus 12 is equal to 0, I know it's going to have 3 answers because it has a 3 right there. And when I graph this one, if I graph both sides and see where they cross, y equals 0 is one of the sides I graphed. That's this line right here. I missed it a little bit there, but that's supposed to be on the axis. And then this one's a cubic, and it usually would look something like this. And there's my 3 answers. And if this one would factor, let's say it would factor, and I could get like x times x squared plus, let's say x squared minus 4 or something like that. Let's say it would factor like that, and then it would factor again, and all of a sudden you'll start seeing your 3 answers. And then I can say, oh, 0 for this one, -2 for that one, and +2 for that one. Those are my 3 answers. So if it's got a 3 here, it's going to have 3 answers. All right, so I'm trying to give you a big overview of what we're doing for like the next couple of weeks. If you understood all of that completely, then this next couple of weeks is going to be super easy. But the main thing is, if I give you a problem like this, that you can solve it by setting this part equal to 0, and that I can do in my head really easy. What's that? X equals 5. Or I could have said x minus 5 equals 0, x must equal 5. And this one, 2x plus 3 equals 0, solve it. There. There's 2 answers. What do the answers mean? They are the numbers that will make the equation equal 0. They're also the x-intercepts. So if I were to graph this puppy, I know that this graph would touch at -1.5 and +5. And it probably goes something like this. All right. Yes, if it's set equal to 0, then the other line, remember this is one line, that's the parabola, and this is another line, it's at 0. But what if the whole thing like equaled 7? Then this whole like solving it, setting equal to 0 won't work, because that's not the zero product property. It has to be 2 things being multiplied that equals 0. If it equals 7, then you got to do it by graphing, because then you'll graph it and see where does it touch and where does it touch. Yes, you could. No, wait. No, you couldn't. Good question. I think what she's asking is this. Here's the normal kind of problem. It said sets equal to 0, then this equals 0 or that equals 0. But if it equaled like 7, then it wouldn't work, because like, let's say I had x plus 3 equals, and x minus 2 and equals 7. Then I can't set this equal to 7, because if I just say x plus 3 equals 7, and then x equals 4, 4, when I put it in here, sure, that'll make this part equal 7, but it won't make that part equal 7. Because when I put my 4 in, I put a 4 in here and a 4 in here, it won't equal 7. 4 minus 2 is 2. 2 times 1 is 2. This answer is 2, is not 7. So no, it won't work if it's equal to 7. It'll only work if it's equal to 0. So this number right here needs to be a 0. Yes, you could, but then these have to be the same thing, the same number. You can't like pick these to be different numbers. You know what I'm saying? X is X. If you're saying X is 4, then I should be able to put a 4 in here and a 4 in there. You can't say X is 4 on this side and 1 on that, you know what I mean? You can't say it's 2 different things at the same time. All right, so the moral of the story is that you're going to have problems set up like this, equaling to 0, and then you're going to have to multiply, or sorry, solve each part. So if it was like this, I would say, okay, this one I can do in my head, x is -3. And this one is 2x minus 7 equals 0, 2x equals 7, x equals 7/2. Got my 2 answers. And one that confuses kids a lot is when it's like this. For some reason, people just get baffled by that. But there's still 2 answers. One of them's -3, and what's the other one? 0. It's just x equals 0, or x equals -3. Okay? If I multiply that back out, the original problem would have said something like this. X squared plus 3x equals 0. You factor the x out, and then it looks like this. And then voila, you get your 2 answers. 0 and -3. All All right, so that's just one way of solving quadratics. I showed you could graph them. We've done the quadratic formula before. Most of you already knew that. Some of you used a different song. I'll have to forgive you. There is many different songs that you can sing the quadratic formula to. Here, this will mess with your head. X equals negative b plus or minus the square root of b squared minus 4ac. And it's all over 2a. You got it. It's the happy birthday song. Oh, I did mess around with it one time, and I found 7 different songs that you can sing the quadratic formula to. So, yep. X equals negative b plus or minus square root of b squared minus 4ac, and it's all over 2a. Anyway, and I just realized I'm recording still. This is not good. Okay, so let's move on. See if I can record. No, I can't record any later because I did my last class of this. Okay, anyway, so I guess I'll have to keep this on there. Is there a way to mute yourself on the editing features of YouTube? All right, anyway. Find your worksheet. I found your worksheet. It's right here. And you can find it in Schoology. And it says Zero Product Property Worksheet. So, what property can you use to find the zeros? The ZPP. Good enough. You don't have to write it all out as zero product property. Yes? Why does the equation of a quadratic function need to be, or no, what form does it need to be in so that you can use it? It needs to be in factored form. Because remember how we factor it like this and it equals 0? Because if it was like normal, let's say it was like x squared plus 2x plus 1, do you see that the answer of negative 1 doesn't just jump right out at you? Whereas if I factor it like this, now I can see the answer really well. Okay, so it needs to be in this form, which is called factored form. In your own words, explain the zero product property. Well, basically that you got 2 parts that are being multiplied, and this part and this times this part have to equal 0, then one of them has to be 0. I mean, say it in your own words. I think you get the idea. All right. And then use the zero product property to solve each of these equations. This will be super easy. X equals, give me one of them. 4, give me the other one. X equals negative 6. Good. When it's that easy? No. Yes, I'm fine with you just jumping right to the answers on those. There's not much work to be shown on that. There'll be some tricky ones later where you'll have to actually solve an equation to get them. All right, let's move on to a little lower in the worksheet. Give you some help on like number 8. See how you feel about that one. Use a zero product property to find the zeros of each quadratic. Oh, that's still easy. Now, notice it doesn't have it equal to 0. Yeah, you have my permission to just take this and put a 0 there. It's okay. You're setting y equal to 0. That is the definition of the x-intercepts. The x-intercepts are when you set y equal to 0. You should be able to fill in that sentence for me. Whenever I say, what are the x-intercepts? You should say, when y is 0. And what are the y-intercepts? When x is 0. Okay. So we want the x-intercepts, so we're setting y equals 0. 0, 0, 0, and 0. And then you just get 2 answers. It's a piece of cake. This one might be a little trickier, so you go 3x minus 4 has to equal 0. 3x has to equal 4. X has to equal 4/3. So you have to do a little bit of work on that one. You should write x equals, and here's the reason. Let's say you have 2 answers, and this one comes out to negative 1/2 and negative 5. Do you get, when I write them like that, it looks like an x and a y, and they're both x's. So it's really not that hard to write x equals and x equals. Okay, so do that. All right, why can't you use the zero product property on this one? Very good, it's not equal to 0. All right, moving on. There is another section at the end that's kind of different, so I want to talk to you about that. Here, it's asking about, basically about graphing. Look at number 13 with me. If you want to get a free answer, do it now. Otherwise, it's going to be off the screen in like a second when I stop recording. Go to number 13. It asks you to graph the function. Well, this is just a quadratic that's been moved what's that? 6 to the left, and what's that? Down 1. So 6 left and down 1. So it's right there. And then I'm going to go over 1 and up 1, over 2 and up 4. Okay, so it looks kind of like that. You don't have to fill it in with a line. You can just use the dots. Are you on number 13? Okay, good. So graph this. Dots are fine. Just dots. I suppose we could go a little farther and go over, and I think it goes off the screen. So, okay, moving on. To get the zeros of the function, the zeros, remember, they're the x-intercepts. So that's one of them, and that's one of them. I didn't even have to factor it. I can just know that they're the places where y equals 0, which are also known as the x-intercepts. So the zeros are x equals, what's -5 and -7? Now, what if you had a tyrant for a boss, and you had to be absolutely positive you were right, or like Saddam Hussein was known for killing people who disappointed him. You did something wrong, he'd just have you killed. And he'd get somebody else. So he was a tough dude. Killed 400,000 of his own people in his own country. So anyway, if you worked for him, you might want to be sure that you were right before you gave him the answer. And let's say that the x is -5, you're not so sure about it. Well, check it. Just stick in a -5 right here. Then this comes out to 1. 1 squared is 1. 1 minus 1 is 0. That's what I wanted. It equals 0. So you can check your answers that way. Just take your number, stick it in the equation, and see if it really comes out to 0 or not. And those do, so we did it right. All right, told you it was going to be gone soon. Now I'm going to go to the last one I want to show you, which is this kind. It says verify that each x value is a 0 to the function. All right, so here, I know that this should be the answer and this should be the answer. But I don't know if this is even the right graph for this. I mean, maybe it's not the same. Maybe they graphed something else. So how do I tell if it's right? I stick in -1 into the formula. Here's the formula. Stick in a -1 there. So I'm putting empty spot squared plus 6 times the empty spot plus 5. That's just this formula right here. And now I'm going to drop in -1 and see if it really works. -1 squared is 1. 6 times -1 is -6 plus 5. Is 1 minus 6 plus 5 equal to 0? Yes, then I verified. -1 works. Now I won't be killed. Yes. So double check your answers. In this case, that's your only job, is to check and see if these two answers are actually the answers. All right, that's how you do your homework for today. You got a little bit of time to work on.